Module 13, Lesson 3, Rotations. The textbook claims this is going to be a one-day lesson. It has 15 resources we're going to have to get through on it. Let's get started working on them. A Ferris wheel is a large upright rotating wheel that has passenger cars suspended on the outer edge. The original Ferris wheel was built for the 1893 World's Columbian Exposition in Chicago. The London Eye is a famous Ferris wheel on the bank of the River Thames in London. It is 43 feet tall, and each passenger car is a fully enclosed capsule that can hold up to 25 people. The wheel rotates at a rate of 10 inches per second. You sign up for a ride on that thing, you're signing up all day. I mean, have you ever been on a Ferris wheel? You got 25 people in each one of the cars in this image right here. 25 people, looks like about 100 cars there. How long is it going to take to load everybody up, go woo 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 a few times, and then get everybody off again? That's a long time, folks. But I have digressed. The London Eye rotates about a central point. The London Eye is similar to the rotation of a figure about a central point on a coordinate plane. The figures can be rotated clockwise or counterclockwise on the coordinate plane, not the London Eye. It only goes one direction. Imagine a right triangle drawn on the London Eye. As the London Eye rotates clockwise about the origin, what happens to the triangle? Well, it's going to rotate around the origin as well, with the right angle staying the same, and then the two end pieces here, the two vertexes on the legs, they're going to rotate around while that right angle stays in the same exact spot. But we need to get started on actually learning some useful stuff. Let's keep moving. A rotation is defined as a transformation in which the figure is rotated or turned around a fixed point. And the center of rotation, well, that is going to be the fixed point that it actually rotates around. So we're going to highlight those two vocabulary words. The rotation does not change size or shape of the figure. So the pre-image and the image are going to be congruent. They're going to be the same exact size and shape. Rotations can be described in degrees and in directions. The phrase a 90 degrees clockwise or a 270 degrees counterclockwise are two examples of possible rotations, and incidentally, it would put the image in the exact location of no matter which way you spun the pre-image. Now we got a video to watch to see how to go about doing all this.
The graph shows triangle ABC with vertices at A, 4, 5, B, 6, 8, and C, 6, 5. A rotation is a transformation that turns a figure around a fixed point called the center of rotation. In this case, vertex A will be the center of rotation. Rotations can be described by direction. A clockwise rotation turns to the right. A counterclockwise rotation turns to the left. Rotations can also be described in degrees. For example, a rotation can be described as 90 degrees, 180 degrees, or 270 degrees. Rotate triangle ABC 90 degrees clockwise about vertex A. Vertex A is the point at which triangle ABC is rotated, so A' will be in the same position as A. Point B is rotated 90 degrees, and point C is rotated 90 degrees. Next, let's rotate triangle ABC 180 degrees about vertex A. In this example, we will rotate counterclockwise. Since vertex A is the point at which triangle ABC is rotated, A' will be in the same position as A. Point B is rotated 180 degrees, and point C is rotated 180 degrees. Finally, let's look at an example of a 270-degree rotation. Rotate triangle ABC 270 degrees clockwise about vertex A. For each rotation about vertex A' will be in the same position as A. Point B is rotated 270 degrees, and point C is rotated 270 degrees.
Well, that does a pretty good introduction of the concept of rotations. Let's see what else they have coming up. Example 1 talks about triangle LMN, and it gives you the vertices of each one, the locations on the coordinate plane that each one of these vertices is located. And it represents a desk in Jackson's bedroom. And you can see here that Jackson has a triangular shaped desk in his bedroom. He wants to rotate the desk counterclockwise 180 degrees about vertex L. Now it says graph the figure and its image. In other words, graph the pre-image and its image, and then write the coordinates for a triangle L prime, M prime, N prime. So let's get started on this. First thing we have to do is graph the figure and its image, meaning graph the pre-image and its image. Then you can see that they have the pre-image already graphed right here, triangle LMN. And then from there we're going to take and do the next thing where they're rotating it 180 degrees around the point L, and the point L is right here. That means that you're going 180 degrees, you're going the exact opposite of where it was when it started. So it says to graph for rotation of an image, use a protractor to measure the rotation of 180 degrees with M as one point on the ray L as a vertex, and then mark off the point the same length as M to be M prime. So what does that mean? We took and made a line here. The straight line is 180 degrees going from M to L. They said, well, how far is L and M apart? In this case, it looks like it's about 3/4 of an inch. Also, if you count it on the box here, tease of a sneeze there, it would be 3 blocks right here. And then from there, if we were to go down 3 blocks, 180 degrees down the line, that's where you're going to put point M prime. Next, you're going to move on and do the same thing for point N. So for point N, once again, they use their protractor, creating a straight line here. The straight line's 180 degrees, and they measure the distance from point L to point N on the protractor, which you can see it goes from 3 inches down to 2 inches on your protractor, so it's a 1-inch thing. So now you're going to come over in the opposite direction on that line for 180 degrees, go 1 inch in this direction, and that's going to end up giving you N prime that they put there. And finally, the last thing you have to do is connect those points with lines, and there you've created triangle L prime, N prime, M prime, or however else you want to say it. The last thing you have to do is write the coordinates, the locations of each point on this new triangle. So L is going to be, remember, Superman runs before he flies, so it's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4. So L is going to take place at point 5, 4. And it doesn't want to let me write that. Hold on. Alright, now I got it working. So that took place at place 0.5, comma 4. We're going to accept that. M is located at 1, 2, 3, 4, 5, 1. So that's going to take place at 0.51. 5, comma space 1. In parentheses, of course. And N is going to take place at 0.21. So we're going to take and plug that in as 2, comma space 1. Except, check our answers. All of those answers check. That's all there is to doing these things. Nothing really hard. Just have to learn how to figure out what a straight line looks like. Now it's going to be your turn. You're going to graph triangle JKL with these vertices, and then you're going to rotate it 90 degrees around the around the vertex J. Go ahead and work on that. I would encourage you to use some graph paper and a protractor in doing this problem. Now it's going to be your turn. You're going to graph triangle JKL with these vertices, and then you're going to rotate it 90 degrees around the around the vertex J. go ahead and work on that. I would encourage you to use some graph paper and a protractor in doing this problem. Alright, the instructions wants us to graph the triangle JKL, which I already did, and find the new image of JKL, which is going to be J prime, K prime, L prime, after a clockwise rotation of 90 degrees around the vertex. First thing I want to do is I'm going to acknowledge that we're going around the vertex J. That's going to be the one we want. So I'm going to take my pen, turn it green, and I'm going to call this location, along with being J, it is also going to be J prime. That one was easy. Next, I'm going to do the easy piece after that, which is going to be K, going to K prime, and I'm going to acknowledge that K is 1, 2, 3, 4 squares away, and that's going to be important to us in just a minute. From here, I'm going to take my protractor, and I'm going to rotate my protractor 90 degrees so it's lined up nice here with our points, and I'm going to run it to where it goes from J to K. I'm going to count up 90 degrees, which puts me right here, and I'm just going to take and put a little tick mark off here north of 90 degrees. Whoops, that's not what we meant to do. Let's zoom back in here, get back where we need to be, and actually turn my pen tool on now. That'll make a big difference. So I'm just going to put a little tick mark up here north of 90 degrees. That's not where we're actually going to be going to. That's just the direction we're going to. From here, I'm going to move my protractor out of the way. Now remember I said that this was 4 units this way. Now I have to count 4 units this way. 1, 2, 3, 4. And when I put my new part in right here, that is going to be the location of K prime. That's our first point. The next point, L prime, is going to be slightly more challenging. To find point J prime, I'm going to take my protractor again, and I'm going to set it up to where that center point is located on J, and I'm going to have to rotate it so that it goes through point L. Now that I have that lined up, I'm going to take and move once again in a clockwise direction 90 degrees, which means we're going to take and grab my little pin here, follow it around 90 degrees, and that means I'm going to be up in this direction. And once again, I'm just going to put a little tick mark up there to indicate the angle 90 degrees is. From there, I'm going to drag this, I'm going to drag the protractor out of the way because it's no longer important to me, and I'm going to bring in a ruler because I need to do some measuring. Now, there's a couple ways you can do this. One of them is going to be a real peel on this. We could take and line up our ruler to where it goes between J and L here and measure out the distance between J and L. But if you're really smart, you're going to recognize that the angle K here is a 90-degree angle. And with it being a 90-degree angle, that means that going from this K, I'm also going to need to go 90 degrees up here. So what I'm going to do instead of, whoops, it fell off. Instead of, come on, quit it, play nice. Instead of doing measuring, I'm going to do a counting. You see, when I count, from K to L, there's 1, 2, 3 spaces. So I'm going to go 90 degrees here, 1, 2, 3, and where's that going to put me at? Right along this line, so that now I'm going to have a dot located right there. That dot is going to be the location for L prime. So I'm going to put my L prime in here. I'm going to draw my line just like that. And that is going to be what the triangle looks like when it's rotated 90 degrees. Next, we need to find the coordinates for each of these points. So the coordinate for J prime is going to be what it was, which is going to be at 3, 1. K prime is going to be at -1, 1. And L prime is going to take place at -1, 1, 2, 3, 4. -1, 4. Let's jump back over to our textbook and where that assignment was, and let's see if we got those points correct. So first one I said was going to be located at 0.31. Internet's running really slow here, so I'm going to do 3 comma space 1, accept that. The next point I said was at -1, 1, so okay, we're going to be putting at point -1 comma space 1, and then L, that's going to be at -1, 4. Oops, I did not include my last parentheses there. -1, 4. So I'm going to take and plug that in. And parentheses, -1 comma 4. Accept and check. And it checks. That does take some time to do. It's not terribly hard once you wrap your head around it. It is a little work intensive though. We're going to end part 1 of the video here, and we're going to pick up on part 2 in the next section.